Welcome back in this lecture of the multiple integral. Today I am going to solve few more questions based on the triple integral, and further I will find out the volume of a solid bounded by the planes. So let us start with the problem. To evaluate the triple integral, so here we have to evaluate the triple integral 0 to 1, 0 to under root 1 minus x square, 0 to under root 1 minus x square minus y square, and then dx, dy, dz upon under root 1 minus x square minus y square minus z square by changing in spherical coordinates. Solution. So here we have to evaluate this triple integral by changing it in spherical coordinates. Now from the limit you can guess that our limits are for the positive octant of the sphere. So here our z is from 0 to under root 1 minus x square minus y square. So we have z square plus x square plus y square equal to 1. Now the spherical polar coordinates are x equal to r sin theta cos phi, y equal to r sin theta sin phi, and z equal to r cos theta. So these are the spherical polar coordinates, and you can see that if you put these values here, then your r will be 1 and this equation will get satisfied. So these are the spherical polar coordinates. Now as we are in the positive octant of this sphere, so our r will move from here. Our r will be from 0 to 1. Just put the values of x, y, z here, and you can see that the radial vector is 1 of 1 unit. And if you want to put this x, y, z here, then you can see that your r is from 0 to 1. As we are in the first quadrant, so our theta will move from 0 to pi by 2, and again our phi will move from 0 to pi by 2. Okay, now we have to evaluate this integral by changing it in polar coordinates. Now by change of variable, our dx, dy, dz will be equal to mod j dr d theta d phi, where your j is the Jacobian of x, y, z with respect to r, theta and phi. And I have already given you the Jacobian of this x, y, z in terms of r, theta in my lecture of the Jacobian, and this was your r square sin theta. Let us transform this integral in polar coordinates and then let us solve it. So we can write this triple integral as v. Now this triple integral will be equal to now your r will move from 0 to 1 and your theta r theta phi. So let us start with phi from here. So phi will be from 0 to pi by 2. Then we have theta from 0 to pi by 2. Then finally we have r from 0 to 1. And your dx, dy, dz is j times dr d theta d phi. So we have r square sin theta dr d theta d phi upon the square root of 1 minus r square. Now let us integrate this one first with respect to r. So for that we can write it as we can write it as 1 minus r square plus r square divided by square root of 1 minus r square. Then we will have sin theta d theta sin theta dr d theta d phi. Now you can see that this is your square root of 1 minus r square, and this will be your r square upon under 1 minus r square. So this is equal to, no, here we have done some mistake, so this has to be, okay, this is just like 1 minus r square. So you can see that now this is your r square. So this is your 1 upon square root of 1 minus r square. So this is equal to phi equal to 0 to pi by 2, theta equal to 0 to pi by 2. Then your r will be from 0 to 1. Now this is your 1 upon square root of 1 minus r square, and you can write it as 1 minus r square root of 1 minus r square, and the second term will be your square root of 1 minus r square, and here we have the square root of 1 minus r square. Then we have sin theta, dr, d theta, d phi. So this is equal to phi equal to 0 to pi by 2, and theta equal to 0 to pi by 2, and r equal to 0 to 1. Now let us integrate this bracket with respect to r. So integration of 1 upon the square root of 1 minus x square is sin inverse x. So this is sin inverse r. Then this integration of this under root 1 minus x square will be x upon 2 under root 1 minus x square plus a square by 2 sin inverse r upon 1. R upon a is 1. So then the limits of r will be from 0 to 1, and we have sin theta, dr, d theta, d phi. Okay. Now if you put r equal to 1, then this will be a sin inverse 1, which is your pi by 2. So we have pi by 2 minus, now the value of this first term will be 0 for both upper limit and lower limit, so it is 0. And if you put r equal to 1 here, then this will be a sin inverse 1, which is again pi by 2. So we have pi by 2 minus pi by 4, and then we have sin theta, d theta, and d phi. Now this will be your pi by 4. So let us take this pi by 4 outside. Now the integration of sin theta will be your minus cos theta. So this will be minus cos theta, and then we have the limits from 0 to pi by 2. Then finally integration with respect to phi. Your cos pi by 2 is 0. Your cos 0 is 1. So we will have plus 1. So this is equal to pi by 4, and then the integration with respect to phi. Now the integration of d phi will be phi. So we have value pi by 2, and it is equal to pi square by 8. Just evaluate the triple integral dx, dy, dz upon x square plus y square plus z square taken throughout the volume of the sphere. Throughout the volume of the sphere. X square plus y square plus z square equal to a square. Okay. So solution, again let us solve this, let us evaluate this triple integral with the help of change of variable. That means we will try to change this triple integral in spherical polar coordinates, and then we will try to evaluate this one. So again, as in my previous problem, here we have to evaluate this triple integral for the volume of the whole volume of the sphere x square plus y square plus z square equal to a square. In my previous question, I have evaluated the triple integral for the positive octane. So there is just slight difference in limits. So in spherical coordinates, we have x equal to r sin theta cos phi, y equal to r sin theta sin phi, and z equal to r cos theta. Now, for the as you have to evaluate the triple integral throughout the volume of the sphere, so in this case, again, your dx, dy, dz will be equal to mod j, then dr, d theta, d phi. Again, your mod j means the Jacobian of x, y, z with respect to r theta phi, and this is equal to r square sin theta, and this thing. Now, as we have to evaluate this triple integral throughout the volume of the sphere, hence, as we have to evaluate the triple integral throughout the volume of the sphere, hence our phi will vary from 0 to 2 pi, your theta will vary from 0 to pi, and your r will vary from 0 to 8. So in this case, our phi will vary from 0 to 2 pi, as we have to cover the whole sphere. So this phi will be from 0 to 2 pi, your theta will be 0 to pi, and your r will be from 0 to 8. Now, let us evaluate this triple integral with the help of this transformation. So, the value of this triple integral v is equal to the value of this triple integral will be equal to, now your phi will be from 0 to 2 pi, your theta will be from 0 to pi, and your r will be from 0 to a, dx dy dz is equal to r square sin theta dr d theta d phi upon, now the value of x square plus y square plus z square will be your, just evaluate x square plus y square plus z square, and that will be your r square. So we have r square. So this r square and r square will get cancelled. Now, first of all, evaluate this triple integral with respect to r. So the integration of dr will be r. So we have the value a. So this is equal to a. Then phi equal to 0 to 2 pi. Then we have theta equal to 0 to pi, and then sin theta d theta d phi. Now the integration of sin theta will be minus cos theta. So we have phi equal to 0 to 2 pi, and then we have minus cos theta, then the limits from 0 to pi, and then finally integration with respect to phi. So again this will be a cos pi is your, so if you take this minus sign outside, then this will be a cos pi is minus 1, then for the lower limit we will have again minus 1, so this will be your plus 2. So this is equal to 2a. Then we have phi equal to 0 to 2 pi d phi, and again the integration of d phi will be phi. So the answer is 4 pi a. So the value of this triple integral for the whole volume of the sphere is equal to 4 pi a. Okay. Now let us evaluate the volume of the sphere. So for that we will assume that this x square y square plus z square is 1. So now let us evaluate the volume of the sphere. So with the similar calculation, evaluate volume of the sphere, x square plus y square plus z square equal to a square. So we have all these things common. So for the volume integral, now your volume integral is equal to volume of the solid is equal to the triple integral, then integral dx dy dz. Now just take the limits. So we have phi from 0 to 2 pi, your theta will be from 0 to pi, your r is from 0 to a, and your dx into dy into dz will be mod j r dr d theta d phi. So this is equal to r square sin theta dr d theta d phi. Now the integration of r square with respect to r will be r cube upon 3. So if you put the limits, then we will have a cube upon 3. Then we have phi equal to 0 to 2 pi, theta equal to 0 to pi, and then sin theta d phi. And again the integration of sin theta will be minus cos theta. So if you put the limits, then we will have 2 outside. So we have 2 a cube upon 3, and then the limits from phi equal to 0 to 2 pi, and then d phi. Now the integration of d phi will be phi, and the value will be your 2 pi. So this is equal to 4 pi a cube upon 3. So this is the volume of the sphere, which is equal to as 4 upon 3 pi r cube, where r is the radius of the sphere. So in a similar fashion, we can have the volume of other solid. Now our next question is, let us evaluate. Our next question is, evaluate this triple integral x plus y plus z x square y square z square dx dy dz taken over the volume bounded by x equal to 0, y equal to 0, z equal to 0, x plus y plus z equal to 1 by using the transformation. Using the transformation, u equal to x plus y plus z, x plus y equal to u, and y equal to UV. So solution. Here again we have to evaluate this triple integral using this transformation. So here we can see that our x will be ub minus y, and your y is ubw. So this will be your ub into 1 minus w. Your y is equal to ubw, and your z will be u minus x plus y, and this is equal to u minus ub. Now as we have to evaluate this problem using this transformation, so by change of variable we have dx dy dz equal to mod j du dv dw. Now here your j will be Jacobian of x y z with respect to u v w. Now I have already given you the Jacobian of this x y z with respect to u v w in my lecture of the Jacobian, and it was equal to u square v. So here I am not going to evaluate this value. I have already given you the solution of this problem in my Jacobian lecture. So this is equal to your u square into v. So we have the value of dx dy dz, we have x y z. So x plus y plus z is u. Now just evaluate the limits using this transformation. So let us guess the limit. Now here you can see that we have x0, y0, z0. Now if x is 0, then we have the value of x as uv into 1 minus w. So from here, your either u is 0 or v is 0 or w equal to 1. If your y is 0, then we have the value of y as uvw equal to 0. So again from here, we have either u0, v0 or w0. Now if your z equal to 0, then we have the condition u into 1 minus v equal to 0. So from here again we have u equal to 0, v equal to 1. Also we have the condition x plus y plus z equal to 1, and the value of x plus y plus z was u. So from here we have u equal to 1. So that means now you can see that your u is varying from 0 to 1, your v is varying from 0 to 1, and your w is varying from 0 to 1. So therefore, limits are u equal to 0 to 1, v equal to 0 to 1, and your w equal to 0 to 1. So if these are the limits, then let us evaluate this triple integral. So this triple integral is equal to will be equal to, now the value of u is 0 to 1, v is 0 to 1, and z is 0 to 1, w is 0 to 1, x plus y plus z is u, so we have u. Your x square will be u square into v square into 1 minus w whole square. Then we have y square will be u square, v square, w square. Then we will have z square. This will be your u square into 1 minus v square. Then we will have the value of dx, dy, dz, which is your u square into v, du, dv, dw. So this is the value of this triple integral. Now let us simplify this one. Here you can see that the power of u is 3 plus 2 5 plus 2 7 plus 2 9. So we have only one term of u, which is your u power 9, and the integration of u power 9 will give you u power 10 upon 10, and as the limit of u is from 0 to 1, so this will be 1 by 10. So this is equal to 1 by 10, and then your v will be from 0 to 1 and w will be from 0 to 1. Now let us guess the terms of v and w. So here we have v square, again v square, so v power 4, then we have v power 1, so this is your v power 5 into 1 minus v whole square. Then we have, let us guess the power of w. Here we have w square into 1 minus w whole square. Now, with the help of beta and gamma function, we can write this integral as v equal to 0 to 1. Then we will have v power 5, 1 minus v square. Then in the bracket we will have w equal to 0 to 1. Now this will be w cube minus 1 into 1 minus w cube 3 minus 1. Then we will have v. Now you can see that this is your x power n minus 1 into 1 minus x power m minus 1. So this will be a beta m comma n. So this will be a beta 3 comma 3. So this is equal to 1 by 10 beta 3 comma 3. Now in the bracket we will have v equal to 0 to 1. Now v power 5 can be written as v power 6 minus 1. 1 minus v whole square can be written as 1 minus v power 3 minus 1 into dv. And this is equal to your beta 6 comma 3. So if you evaluate this triple integral, then this is equal to 1 by 10. This will be your gamma beta m comma n is gamma m into gamma n upon gamma m plus n. So this will be gamma 6. Here we have gamma n into gamma n upon gamma m plus n. So this is gamma n. Now your gamma 6 and gamma 6 will get cancelled. Gamma 3 is factorial 2. So this is your 2 into 2 into 2. So we have 8 upon 10. So that means 4 upon 5 into 1 upon gamma 9. Gamma 9 is factorial 8. And just guess the value of factorial 8. This will be your 8 into 7 into 6 into 5 into 4 into 3 into 2. So this will be your, just guess the value of this one. So 8, 7, 6, 5, 4, 3 and 2. So this 4 will get cancelled with this 4. Now in the numerator we will have so if you want to calculate this value, and this will be your 180 multiplied by 56. So and then again multiplied by 5. So this is your 90 into 56. So this is equal to 900 into 56. So this is equal to 6. So this is equal to 4. So this is equal to 1 upon 50400. So this is your answer. So this is the value of this triple integral using the transformation u equal to x plus y plus z, x plus y equal to ub, and y equal to ub double. Now our next question is now let us evaluate the volume of the tetrahedron. Evaluate the volume of tetrahedron bounded by the plane x upon a plus y upon b where z upon c equal to 1 and the coordinate axis and coordinate planes. Solution. Now let us find out the volume of this tetrahedron which is bounded by the plane x upon a plus y upon b plus z upon c equal to 1 and the coordinate axis. So this is your y axis and this one is z axis and this one is x axis. So this is your tetrahedron, and in this xy plane we will have x upon a plus y upon b equal to 1, and it is given that the plane x upon a plus y upon b plus z upon c equal to 1 and which is bounded by the coordinate plane. So we will have x positive, x equal to 0, y equal to 0 and z equal to 0. Now let us guess the limits. So volume integral will be equal to the triple integral v, then dx, dy, dz. So this is equal to, now let us guess the limits. So here we will have x equal to 0. Now at this point we will have x equal to 0, a. So your limit of x will be from 0 to a, then your y. Just take your vertical strip in this plane. So your y will be is equal to from 0 to, if you calculate the value of y here, then this will be your v time 1 minus x upon a, and the value of z will be from 0 to this value of z in this plane. So this will be a 1 c time 1 minus x upon a minus y upon b, and this will be dx, dy, dz. So here we have z equal to 0. Now in this plane our z will be equal to 1 minus x upon a minus y upon b. So this is your volume integral. Now let us integrate first with respect to z. So the integration with respect to z will give you, so this is equal to x from 0 to a, y from 0 to b into 1 minus x upon a. Now the integration with respect to z will give you c time 1 minus x upon a minus y upon b into dx, dy. Now let us integrate with respect to y. So on integration with respect to y, we have the integration of 1 as y, then we will have xy upon a, then we will have y square upon 2. So this will be y square upon 2b, and then integration with respect to x. So this is equal to c, then x equal to 0 to a, now y. The limit will be from 0 to b into 1 minus x upon a. Just put the value of y, so this is your b into 1 minus x upon a, this is your x upon a into y is your b into 1 minus x upon a, and here we have 1 upon 2b, put the value of y, so this is your b square and 1 minus x upon a whole square, and then the integration with respect to x. So this is equal to, now, so this is equal to c equal to 0 to c into the limit of x from 0 to a. Now if you want to simplify, then you can simplify it. So this will be b into b upon a into x, then we will have minus b x upon a, then this will be a plus b x square upon a square, then there is no need to simplify this one, so this will be b upon 2 1 minus x upon a whole square, then the integration with respect to x. Now let us integrate this bracket with respect to x. So this will be your, now integration of b with respect to x will be bx, then we will have integration of xh. Now this is your 2 times, so the integration of x will be x square by 2, so we have b upon a into x square, then the integration of x square will be x cube upon 3, so we will have bx cube upon 3a square, then we will have minus b by 2. Now integration of this bracket will be x cube upon 3, so 1 minus x a cube upon 3, now divided by this minus 1 upon a, so this will become your plus, and this 1 upon a will go in the numerator, so we have a, and then the limits of x from 0 to a. Now let us put the value of x equal to a and x equal to 0. So if you put the upper limit, then here we have x h a, so this will be b into a. Here we have to put x equal to a, so this will be your a square, so just it is equal to minus b. And here if you put x equal to a, then this will be your a cube, so we will have b upon 3 into a. Then here we will have b a upon 6. Now for the upper limit, this will be your 0 because we have to put x equal to a, and this will be 1 minus 1. Now for the lower limit, put x equal to 0, so this will be your minus b a upon 6. So this is equal to minus b a upon 6. So now for this part, as we have to put x equal to a, so this will be b a. So this b a and b a get cancelled. So now this will be your 2b minus b a. So this will be your b a upon 6, and this is your a b c upon 6. So that means the volume of the tetrahedron bounded by these 3 coordinate planes, bounded by this coordinate, this plane, and the coordinate planes is equal to a b c upon 6. Now if your a b c are equal to 1, then this will be your just equal to 1 by 6. Now our next question is to find the volume of the cylinder Now, in the next question, we have to find the volume of cylinder bounded by the cylinder x square plus y square equal to 4, and the planes y plus z equal to 4 and z equal to 0. Solution. Here we have to find out the volume of this. Here we have to find out the volume bounded by this cylinder and by these 2 planes. So let us draw this figure. So here we have, say this one as x-axis, this one as y-axis, then this one as z-axis. Now here we have a cylinder x square plus y square equal to 4, so that means this will be just like this one. So this is the circle with the radius 2, then now this is bounded by the plane y plus z equal to 4, so again. So this will be like this is your plane, y plus z equal to 4. So we have to evaluate the volume bounded by this cylinder. Here we have to evaluate the volume bounded by this cylinder. So this is your cylinder, and the plane, this is your y plus z equal to 4, and the plane z equal to 0. So the plane z equal to 0 means this xy plane. So this is your cylinder, and here we have to evaluate the volume of this portion. So for that, now let us take, here I am using the Cartesian coordinates. So if you take the strip here, now this is your circle. So here we will have y equal to plus 2, and at this point we will have y equal to minus 2. So the volume of the cylinder will be equal to, so in this case, now if you want to guess the limit of x here, then you can see that our limit will be, this is your x square plus y square equal to 4. Now at this point our x is 0. So if your x is 0, then your x will move from 0 to a square root of 4 minus y square. So your volume of the cylinder is equal to, so volume of the volume bounded by the cylinder, here the volume bounded by the cylinder is bounded by the cylinder, and y plus z equal to 0, 3, 4 and z equal to 0 is given by, so this will be your equal to, now the value of y will be from minus 2 to plus 2, and your x will be from, okay, now here you can see that your x will move from minus under root 4 minus y square to, your x will be your, just take the upper part, so this will be your x equal to 4 minus y square, and then your z will be from 0, take a vertical strip, then your z will be from 0 to 4 minus y. So this will be 4 minus y, and for volume we have dx, dy, dz. So this is the volume of the solid bounded by this cylinder, and y plus z equal to 4 and z equal to 0. Now let us evaluate this integral, triple integral. So first we will integrate with respect to z. So the integration of z will be 4 minus, integration of dz will be your z. So this will be 4 minus y. So this is equal to y equal to minus 2 to plus 2, then we have x equal to minus the square root of 4 minus y square to the square root of 4 minus y square, then this bracket will give you 4 minus y, then we will have dx into dy. Now let us integrate with respect to this x. So if you integrate with respect to x, then we will have y equal to minus 2 to 2. Now the integration of x will be, integration of dx will be x. So if you put upper limit this one and lower limit this one, then we will get just 2 times the square root of 4 minus y square, because this is your x. For the upper limit we will get plus 1, and for the lower limit again we will get plus. So this will be 2 times into the integration with respect to y. Now we can write it as 2 times y equal to minus 2 to plus 2. Now this will be your 4 times this one. So we have 4 into square root of 4 minus y square, then we will have minus y into square root of 4 minus y square, and then integration with respect to y. Now let us integrate this bracket. So it is equal to, now the integration of a square minus y square is equal to y upon a. So this will be 4y upon 2, then 4 minus y square, then we will have a square upon 2. So a square upon 2 means 4 into a square, your a is 2. So a square upon 2 means 4 upon 2, then we will have sin inverse y upon a, your a is 2. So this is integration of the first bracket. Now here, again you can write this bracket. If you integrate this, if you take this bracket as minus t, if you take this bracket as t, then integration of this bracket will be, if we take 4 minus y square equal to t, then this will be minus 2y dy equal to dt. So we have minus y dy equal to dt upon 2. So this minus y into dy will be dt upon 2. Now this is your square root of t. Now the integration of square root t will be your t power 3 by 2 upon 3 by 2. So this is equal to, the integration of t power half will be t power 3 by 2 upon 3 by 2, and this 2 will get cancelled. So we have t power 3 by 2. So that means 4 minus y square power 3 by 2 upon 3 upon 2. And with the help of this 2, our 2 will get cancelled. So we have just 3 here, and then our limits from 0 to, from minus 2 to plus 2. Now let us put the limits. Now again, in this case, in this first term, if you put upper limit or lower limit, this will be 0 for the both case. Now this is equal to 2 times, now this is your 8 into, now for the upper limit we will have sin inverse 1, and your sin inverse 1 is pi by 2. And for the lower limit, we will have sin inverse minus 1, which is your minus pi by 2. So again we will have plus pi by 2. Now coming to the third term. Again this third term will be 0 for both upper limit and lower limit. So this is equal to your, this will be your 2 pi upon 2. So this will be your pi. So this will be just 16 pi. So that means the volume bounded by this cylinder and these two coordinate planes, these two planes is equal to 16 into pi.